I want to talk how to avoid compilations, how to get your code compiled without actually waiting for compilation to finish. Before I start, there is an application, you probably know that you can vote. And before we go even further, let's start some compilation. So this is what I got here is enzyme server. First, I want to do a clean. I will kick the compilation of everything. And now I don't need to wait, I can do other things. So now I can introduce myself properly. So as I said, I'm Krzysztof, I'm from Virtus Lab, and where I work on creating a tooling for quite big workspaces using Scala. To get you some context about the workspaces, this is a big monorepo with over 2 million lines of Scala code, over 200 developers working on that code. It means like 13 PRs get merged to the main branch every day. And compilation time, which is the biggest problem, take over 40 minutes. And the machine that we compiled is quite powerful. It's almost a server, like 6-core Xeon processor, 32 gigabytes of RAM and SSD drive. So this is not a normal laptop. And there, despite of any other problems with this kinds of workspace this big can provide, we try to fix the compilation times. And approach, everything I will mention later on, it's being developed for that workspace. It's quite a different form, but the idea is the same. And we got it on production right now, and I was able to cut down the compilation time from 40 minutes up to 8 at some point. So we are quite happy. In normal case, it's like 20, 25, and you will see later on why. So first, we probably should look at the compiler, and why it's so slow and how slow is it. So right now, I want to ask you to raise your hand if your standard normal incremental compilation takes around 10 seconds. Nice. If this compilation take around a minute, like a normal incremental one? Okay, most people there. 5 minutes or more? Okay. And is there like anyone that is like 15 minutes or more for an incremental compilation to finish? Okay, I see. I see your pain. I was on that place. So this is the numbers I took from open source libraries. Enzyme server, Scala debugger, Akka. It's like I take one pull request and compile that against previously code was compiled, and the times are like what most of hands was shown. I mean, around a minute, less than a minute, something like that. And I think this is what we can live with and we are happy with. However, we still sometimes we need to do something to get this out of the Facebook. But yeah, with incremental one, we can live. And I don't know if you noticed, there is cold and warm numbers here. So it's unrelated to the stock, but please keep your SBT or JVM hot when you compile the stuff, because it will means that the compilation will be faster. Even almost twice in case on enzyme server. It was exactly the same change, compiled on the cold, I mean, just started, and the SBT instance that was compiled few things. So just for the sake of your time, keep your SBT open all the time. And the picture changed when you go to the full build. So again, I want to ask you a question. Whose workspace compile in 10 seconds if this is a full build? So we do clean and then build. Okay, no hand. I expected at least one hand. Around a minute? 5? Around 15? And is there like anyone that compiles for more than 15 minutes? So this is probably talk for you guys. And yeah, the numbers from the open source project are pretty much the same, around like 3 to 5 minutes. And this is not only that we took this 5 minutes that we need to wait. The problem is that when it takes like 5 minutes or more, we don't want to wait that much. So we're doing other stuff, like fencing with our friends, or doing a coffee, or going for lunch. And okay, we are doing something, we are not wasting time, let's say. But the problem for me is that we lose all the context that we have, that we like develop something really nice and then we have to do full build because, I don't know, we break our SBT or for some other reason. And then, after this 10 minutes, we completely forgot what was there before. We need to build this plan, we need to build the caches in our head again. And this is a bigger problem, because we might even forgot the perfect path that we want to do with the refactoring. Now it's gone, and we had to scratch our head. What was the perfect name? What's the pattern I have to apply here? So that is why in this presentation, I want to make all of the compilation incremental. I mean, in terms of the time they take. So whenever you can, like even for CI, or you just break your workspace and you want to do it again, or start from this new branch. What I want to do, I want to make this compilation incremental, or even almost no-op, in the best cases. And I think right now is the perfect time, so I show you what we can do. So our compilation finished. Oh, sorry, it's almost exactly 3 minutes. So let's do something. I don't know. You can see this clearly or not? Cool. Okay, so let's do a clean. And now, before I hit compile again, let me just call this magic command called /apply. It will take a while. It will print something to the console. It's quite early stage, so right now I print a lot, like takes 6 seconds. And let's do a compilation again. It's formatting, and we're done in 4 seconds. And you have to believe me that I didn't play with clean. It cleaned the workspace, and I mean, I can run tests. This is test setup, nothing got compiled, everything is fine. So we was able to cut down the 3 minutes compilation into 4 seconds, or maybe 10 if you compare 2 commands together. And this is the kind of results I want to achieve with my plugin. Because you just met Hoarder, and Hoarder is the thing that allows you to do such a quick compilations. Just not to confuse anyone, this is not the Hoarder. So nothing to do with Game of Thrones, this kind of stuff, because the guys was like a little bit confused. This is a Hoarder, so like guys that accumulate all the stuff together. And yeah, as I said, this is an SBT plugin. It's released. I'm still working on that, so it does not have a stable release, but I think I'm close to that. If you are interested, it's on my GitHub, and if you type in Google Hoarder Scala, it should be the first result. I hope it was yesterday, so I hope it's still. Okay, so what is it all about? How does it work? So what I'm trying to do with Hoarder, I'm trying to mimic compilation. This magical command /apply try to mimic the compilation. So there is a cache somewhere where because I didn't speed up the compiler like 20 times. If not, I would be like presenting on the main stage, and everybody will be so happy about that. I'm not that smart. And yeah, so what I did here is basically I'm trying to when I take the cache, it's generated after some compilation. I try to apply that cache, and when I'm applying that cache, I try to mimic the compilation. So you can think of that you just come back to the place, to the source, to the workspace where the cache was generated, hit decompile, compile these things locally, and then come back to the state of the workspace that you are currently in, and run incremental compilation. Right now, it makes no sense because you pay a lot of time for the incremental compilation, changing the context, but it's all cached. So the cache, applying the cache was like 6 seconds for the enzyme server. So we can pay this amount of time because it is mostly PY operation, copying the few zips and extracting them. So nothing really hard, nothing really heavy. And why I believe that incremental compilation and cache, this connection is so powerful. The biggest problem when you got a cache is when you have to invalidate that cache. But for me, I don't have to do much about that because incremental compiler is here for me. Because what I'm doing, I'm basically doing that. I'm telling compiler, okay, this binary classes was recompiled in this kind of configuration with this metadata. So find the changes and recompile them. Also, if you got a cache, sometimes you need a direct hit. So either you got a cache or not. With incremental compilation and caching, you can be like in the halfway. You can be like, I don't know, 3 commits away from cache, and you will still benefit from the cache. Because what is changed, incremental compiler will detect that change and compile it for you. And we pretty much are happy with how incremental compiler works for us. I mean, is there like anyone that complains a lot about incremental compiler? I know what you mean, because I see some edge cases, but in general, it's not that bad. Or even if something is broken, but in 95% of cases, we are fine, we can pay this clean compile time this time. So it's not that big of a problem. And the third thing that is so powerful here is that we don't need a full cache. So for example, one of the workflows I will mention later is to provide them incremental compilation metadata to released code, because there is the binaries lying all over the places, like my Maven repository. And for me, all these places are potential caches. But problem with the release is that it contains only sources from the compile scope in most cases. But with incremental compilation, we are fine, because the rest, the tests, will be recompiled on the spot. So we can still benefit from the reduce of compilation time. I said a lot about cache, but what the cache exactly is? It's two things: binaries, so class files, nothing to say more about that, just zip class files, and the metadata, that this is a transformed Zinc analysis. And I don't know if you know how Zinc or SBT incremental compiler works. Yeah, this is what I expected. So this metadata is the key for all this. So it describes all the relations between sources, it describes relation between libraries and sources, and describes the state during the last compilation. So that state is, for example, where the output is, what is the compiler options, what is like, it also like the hashes or the stamps, how this is called in Zinc, of the libraries and sources. So with that state, we can like compare the state with the state that we have currently and find the places that are changed. The same goes with relations. So basically this metadata is the key to find what really needs to be recompiled based on what is changed. You want to access one, it's not that hard. If you do an SBT show int compile setup, you will get case class printed, and the fourth parameter in that case class is a path to that file with this metadata. It's usually something like that. And if you want to use that, because it's quite interesting information can be found there, like for example, which classes comes from which source, or which library is used where. And if you want to do that in some kind of tool, you can do that by accessing cache directory in int compile setup task, and the file there is controlled by compile analysis file name setting. And if you don't want to do that, I can do it. I can show the like small file for you, and this is what all of your workspaces have a lot. So each scope, each configuration in each project, wherever there's at least one Scala sources, generates something like this, where all the information is stored. The output is quite terrible, in my opinion, but it worked, and nobody cared because it worked. Right now, there is a lot of work around Zinc, and Zinc is incremental compiler taken out from SBT, in short words, and they plan to use something sane here, like, I don't know, proto-buffs. There is a debate how to keep that. And you probably can notice that there is paths like this. So the paths are absolutes, and that are absolute. And it's not only the paths that are absolute. It's much more things that make this metadata, workspace specific. So you cannot just copy the class files and this file and put it in another workspace. It will not work, because like absolute paths, maybe we will be able to fix that because we know the output, we know where the sources is in the Zinc. Maybe we might use relative paths. But there is more. For example, you got IV caches where all the libraries are stored, and there it can be different on different machines, and Zinc has no idea if there is a jar, if it's like comes from this dependency or another. And we can change the output locations, and to be honest, if you change output location, there is no classes there. When we use the cache, why do we need to recompile everything? Because of the output changes. There was a question on Stack Overflow, and somebody asking that why, when I renamed the top level name of the workspace, everything gets recompiled. Because of that, because of the absolute paths. And we go into also more unobvious things like line endings. If you want to use a cache generated in Linux on Mac, there is a good probability that it will not work because the line endings are different. And the last one is the bug that I actually have in Hoarder. I mean, I forgot to map the location of Java. So yeah, that is why you cannot just take it, analysis, and copy to different project and think that it will work. But there is a solution for that. Of course, you can try to, like, in text, replace all the values, but I don't think it will work in the longer term. So what I did in SBT 1.0, I mean in Zinc 1 and SBT 1.0 the same way, I created something called analysis mapper that actually mapped each of the things that can be mapped, like source location, library location, or stamps, or even the file configuration. And you can provide this mapper, and you can control what is where, and you know exactly what the context are you in. So you know that this is a source, this is a library, this is a product, so it means classifies. So you can play with this value, and you are like top level, like you're looking from above because you are working with the build infrastructure, like in SBT, for example. So we know, like, there is a jar on class path, but I know exactly what is the dependency that it comes from. I know what the library. So if it's like just cache from Maven repository between two machines, if the publication date is the same, it's the same jar, if everything goes right, and most likely do. So we don't need to recompile everything. And when we apply this mapper to the cache before, we get something like this. It's much shorter. As you can see, all the paths are replaced with some text format. Once the SBT moves to protobuf or other proper format, it will also change. So right now, I'm using what I face, but it works, and I don't see any problems with that. And this is all what we can talk about metadata. So I think right now it's a good time if you got any questions about the general idea, because how to use that, there is much more slides after this one. But if you got any questions about the general idea, the general engine, this is a good time. Okay, there's one. Okay, what is the key to the cache? At this level, there is none, because the key to the cache is in the next slide. It's the how we can find the cache and apply the cache. Okay, so let's go further. Yes, so how you can use that before you can move anywhere there, just apply plugin to your SBT project. Or if you want, because there is also the basic plugin, this is auto plugin, so it applies automatically all the changes to your project. Does not change, does not alter any of the predefined SBT tasks, and I like only the commands that are designed to be called by users are without any prefix. The rest of the settings and the commands is prefixed with Hoarder. So it's pretty safe to add it to your global SBT plugins. So it will be applied, this plugin, to all of the project that you work on given machine. You just add this, and you can work with basic stuff like stash, what I just showed you. So right now, I generally think when I develop new features for Hoarder, I think in terms of workflows. Why is that? Because the way how you generate the cache determines how the cache is used. So you cannot, for example, mix these two. Maybe you can, but you probably shouldn't. Like, if you got cached release and you want to like stash using stash methods up to get the results from that cached release, at this moment it will not work. Later on, maybe. But in general, you should like think in the workflows. What I mean by workflow, so how cache is generated, how we can find the cache, and how we can apply the cache. And at this moment, there is 3 workflows supported. The last one is still a beta feature, because I just create the test, integration test, I run it locally, it works, committed the change, but I don't do any extensive testing around that, and I'm not quite sure exactly if there is any information published, so please don't publish anything with this to the Maven Central at this moment. Or if you want to leave on the edge, it's your call, I just warned you. So let's look at the first one. That is called stash apply. You probably see the similarity to the git stash and git stash apply workflow. It is exactly what it does. If you got a compilation, you just call git stash. The result will be stashed on this side. You can then play with the code, change it, change a branch, then come back to the same point, and you don't want to recompile the code again, so you just call stash apply, and the compilation is back. So it can be used anywhere. Like you just, it is probably the only workflow that will work if you if you use a global plugin, because it does not require any configuration for on the project, because none is required. And you are responsible for for being sure that if you stash something, then you unstash or stash apply the correct thing to correct place. It's similar to the git stash. It's all up to you. For me, this is really useful because this is the simplest workflow, and it's really easy to write the integration tests, and I got a lot of them using that stash to test a core features, like, I don't know, if given library is properly mapped. It's quite easy with stash because there is no much things around that. More documentation can be found on GitHub, and right now I think I can show you more or less how you can use that. So let's back to the same thing. You saw the stash apply, so let me show you how stash command work. So this is the simple command, and it takes two optional parameters, two labels. By default, there's one, like project and version. Project is the descriptor of the whole project as a multi-project build of SBT. By default is the name of the top-level directory, and the version is head by default. But we can provide any things like, I don't know, Scala Days, for example, version 45. And it will just publish few zips and like few zips, one with analysis, some with classes on the site. And as you can see, it's stored in the global directory where, like, for example, SBT caches its instance or other global stuff. Of course, this can be changed. There is the default settings for everything, so you can you can choose the place that suits you more. And to apply that cache, first, well, you want to clean, so we're really testing something. Stash apply, and we should be good to, for example, run test directly. It's formatting, I cannot control formatting, and yeah, the test started. I probably shouldn't do that because now I have to wait. Anyway, there is a checks build, like you cannot publish to the same cache twice, but you can change the default settings to false, and you can do that now. Of course, when you try to access cache that does not exist, it will also fail. And there is one more command that you can use. It's called cache stash clean. That if you want to clean given entry, you can do that. This works fine with the cross builds because the cache is prefixed with the Scala version. So you should be free to, like, if you do want to stash and stash apply artifacts for multiple Scala versions, it should work. Second integration I created for Hoarder is for the pull request verification. You probably should be worried that I want to use incremental compiler to verify the pull requests, because we know that incremental compiler is a heuristic. So why I suggest you to use to use incremental compilation on the pull request verification? First of all, even if you do like the compilation from the scratch, even if you test on multiple machines, but you can still got like when two pull requests in the same time are green and they are merged back together to the master branch, the build might fail from the master. You are not safe. Or if you got the code that has a build, but they're quite old and they are incompatible with the current state, they might be not. We don't need a git conflict to break the main branch. So that is why you really need to run a lot of stuff, a lot of pull request verification to be just sure. Whenever you merge something, you need to retrigger all of the previous pull request verifications. And this is quite like requires a lot of machines to do that, or a lot of infrastructure, and moreover, it requires a lot of time to wait. If you got multiple users that at the same time want to merge a lot of stuff to the main branch, like as I said, there is like 40 pull requests, or 30, sorry, pull requests per day, each day in the workspace I work with, and the problems like that are like almost like once a week the master is broken, even if we do extensive testing, like, and the pull request verification, it takes like an hour to complete. So you probably, I mean, I at least want my pull request verification to be quite fast. Why is that? Yes, I tested my code. I tested the code locally. Maybe I didn't run the whole test, but I want to test, for example, the same code on the Windows. I don't develop code on Windows, and I don't want to wait like 10 minutes or 15 minutes for a compilation to finish before. But I know that I changed only one thing, and I know that incremental compilation will work fine because I did it on my machine. So that is why I suggest this pull request verification build. And for the unstable build, what I can suggest is that you should do post-merge builds to verify the code. Then you will be completely safe. And in the same time, if you do that post-merge builds, you can generate caches. And those caches can be used for next pull request. So now you can reduce, I don't know, you can reduce the time required to compile the pull request to 10%, and basically the time that you have to wait on your machine to compile that pull request. As I said, it requires post-merge builds because the cache needs to be generated. And with this combination that you have your branch, you have post-merge builds, and whenever the post-merge build failed for given pull request, then you know that you need to just revert that pull request back and fix the problem. You can do some kind of staging branch, that is intermediate branch before the code go to master. And this works quite well because then you can, like, when you try to do a release, for example, you can just write extensive event like the testing with the some kind of QA teams or whatever you use to test your code. More on that is again on the docs, and you probably think that setting up something that hard on this infrastructure requires a lot of changes. I want to prove it that it does not, because this is all the changes I need to done to make to make all the compilations incremental for a pull request verification for enzyme server. So there is 4 changes that you need to do. First, you need to surround the SBT task with pre-build and post-build task. Then, the second thing, you need to add a cache directory. By default, is Hoarder cache to the Travis cache definitions. You need to create one object that extends from pull request Travis PR verification plugin base, and you need to add a Hoarder plugin. So even if you have no idea how SBT works, you should be able to do that. Because I know that SBT has no learning curve, it's a learning cliff, and it's really steep. So that is why I try to provide as SBT-free configuration as possible, just for everyone to be able to access that and benefit from Hoarder. So let's see if we can create our own integration with, in this case, Amazon S3. So the caches will be downloaded from S3, and after when you want to generate one, it will be uploaded to Amazon S3. And I promise no SBT knowledge is required at all. So this is all what we need to do. Sorry, but I got some problems with ID just before the presentation, so there is no code coloring on this one, sorry. So there is no SBT. No SBT mentioned nowhere in this file, and the only thing that you need to know to make it work is just that you need to place this file inside the project directory in your build. And what we have to do? First, we need to provide the bucket name for Amazon S3. I don't know if you're familiar with Amazon S3, but this is the identifier where the build will be placed. And there is 2 methods that we need to implement from the one-table cache setup that basically describe how our cache will work. It's dolant cache and upload cache. So this one will be invoked just before the cache want to be used. So we need to dolant cache to specific path. And on the other side, when the build is done and we want to publish cache, upload cache will be invoked with the complete cache in the path. And we just need to send it to S3. I know this is silly. I mean, the integration with S3, you can replace that with proper, I don't know, Java integration. But with this form, it fits on the slide. So, and be honest, sending something to somewhere isn't that complicated. And this is a normal Scala code. You can do whatever you want here. There is few more methods like should publish cache, should use cache that basically control if you want to use a cache. You probably should read a local variable, whether it's a pull request verification. If there's a pull request verification, we probably should use cache and we shouldn't put publish cache. But if you are post-merge build, we should do the opposite. So we should not use cache, compile everything, but we should publish cache in the end. Last thing, in this file, in this class, is just to clean the cache. Again, another Amazon S3 command, and we just described how our caching will work. And the last thing that you need to do is just create another plugin base. This works using auto plugin for SBT. So it basically means that it will just apply these settings to all of your projects without touching any build definitions. Let's see if we can make it work. So let's switch to another project. It's called Unicorn, and this is the Virtus Lab open source kit for Slick development. And yeah, first we probably do it like from the backward. So first let's publish a cache. So post build. I hope internet connection is fine here. So we can publish. Yes, so we just publish our caches. As you can see, there is an output from Amazon uploading the caches to the bucket. So right now we can just clean our workspace. And let's imagine right now that we are on the pull request verification job. So first we will call pre-build, where we resolve all the dependencies. And we will download our cache from S3. And right now we can, for example, start a compile to see if all is fine. Yeah, 1 second and we are done. Of course, this is quite a little bit of cheating because we exactly published the same code that was recompiled, so there was nothing to compile. But you need to trust me that next compilation will be incremental as 1. So if we change one file, only this one file will be recompiled, or any other files that need to be recompiled because of that change. So, as promised, no SBT knowledge is required to use that. And the last thing that is supported as a beta is cached released. So I mentioned this during the presentation, that there is a lot of classes lying all over the places that we can use to speed up our builds. And this is one of the examples. So what we want to do here, we want to add another artifact to our release, and that contains incremental compilation metadata, and later on, use that release with all this incremental compilation metadata to speed up builds in our local workspace. So for that, there is a command called load release that you need to specify the version, and this version is exactly the version what the binaries was released previously. How does it work? It just try to resolve ourselves with given version, try to download the binaries and metadata information using Cursor. So not to like play with SBT, so not to accidentally add ourselves to the class path, and use the incremental compilation metadata and classes to speed up the build. In future, I want to support like a placeholder for a version, like placeholders for a version like current and last. So we don't need to remember it was 1.3.6 and 7. So SBT will be able to like look, for example, on the Git history and find the last tag with the last release. But at this moment, it is not supported. More, but really not a lot of is on the documentation because it is beta, as I said. And you probably want to know how big the incremental compilation metadata are. So this is from the Unicorn library, and as you can see, this is a little bit streamed output of the LS. You have to believe me that there is nothing new added to the docs, IVs, and POMs and the sources, but you can check it yourself. But what was most interesting, there is this new type of artifacts called compile Hoarder caches, and the main thing, the zip with the analysis, it's like 20 kilobytes, not that much. If you compare that with the size of the jar, that is 4 times the size, more or less. So there will be the releases will be quite bigger, but not that much. And let's see if it works. So let's do a publish local. Oh, it takes a while. Okay, we know the version. Probably should do clean. Again. Of course, we need to resolve all the dependencies, because when we clean the workspace, I don't cache the resolution mechanism. Probably we need another plugin for that. And let's see if we can compile our workspace again. Yeah, so it worked. Of course, you don't need to worry, because I changed the project definition, and you need to explicitly specify that you want to publish something more, because I don't want that. I mean, in my opinion, like adding something automatically to your project that will publish something more to the Maven, it's not quite a good idea. But you just need to add one settings to your project definition. I still don't have like the last form of the how it will be applied. That is why I'm not showing you it right now, but it should be quite simple. Of course, this is not like the whole project. I mean, I got a lot of plans for future, and the most important one is that I need a feedback, because I have a feedback from the workspace I work with. This is just quite different tools and quite different integrations. But I need a feedback from you, because this is in that workspace, I know very well how user works, what is the patterns, the behaviors, and they are probably different in your teams. So if you want to use Hoarder, just please give me the feedback how you use that, how you work with this library. And more plans, I want to support SBT 1.0. I want to at least try to implement support for IDEs. We will see how well it works. Next thing I want to do is incremental aware library dependencies. It's probably a bad name, but I don't get any better one. What's going on here? So if you got a common library that you work with, for example, I don't know, user integration, database connections, stuff like that, that is in the different SBT project. And you need to develop it alongside your client application, let's say. Whenever you change something to the library and want to use that changed version in your project, it means that every compilation will be full. I mean, full in the terms that every usage of that changed library gets recompiled, because there is no incremental compilation information attached to that library. And with cached release and few changes in SBT internals, maybe I will be able to change that. So whenever you change one method, only usage of that one method will get recompiled in the client library. This might be tricky to implement, because SBT, especially internals, are really tricky. And new workflows, I want to abstract as much as possible, so it should be quite easy, probably without any SBT knowledge, to add a new workflow. I want to find a little bit automatic cache detection mechanism, like based on tag, commits, under like maybe some files in your workspace, I don't know. And I also want it to be abstract, so you can provide your own, quite easy. And the holy grail of this project is automatic cache application. So you don't need to think about any command, you just do a compile, and internals will decide whether the cache should be used or not. And in the integration I mentioned, the big project, we got it working, and it working quite well. I mean, nobody complains that the normal compilation are slower, and the full builds just reduce the time, and the user is happy. But I am able to manage that because I really, as I said, I really know, I well know what user will do, how they work, what is like the size of the code base. So I'm able to play with the numbers. For everybody, this is tricky, but I got the idea how to make it work without any guessing. So yeah, I hope like in a year or two, I will be able to have this automatic cache application. And this is all from the presentation. And now is the time for the questions. I see one over here.
Thanks for the talk. I'm pretty sure you'll get some feedback from us, because this is very cool. I have a couple of questions. First is, maybe I have missed that because I came a little bit late, about the multi-project build. So I have like 5, 6 projects, and I want to and I have like 2 and projects that are like being launched, and a couple of projects are like libraries for that. So how do I provide like a single cache to compile all the projects? Like, do I have to use some aggregate project or aggregate root project that like is like depending on those? Yeah.
I see what you. So the question was, if you got a multi-project build, do you need to do something more, or is it just supported out of the box? It's the latter, so it's supported out of the box. So in cache, you got the entries are prefixed with the project name and the configuration name. So there is different scope for tests, for, I don't know, whatever, for compile, for any other scope that you have. And also there is a prefix for Scala version. So you can quite easily, like if you change the Scala version, you can publish the cache in the same place and it will work.
Yeah, but do I have to, for example, if I use stash and stash apply, do I have to stash for each project or not?
Okay, you don't need to. The second question was, do I need to stash for each project? No, the stash is aggregated. This is the setting for each task. So if you do it on the top level, it will do it for all projects. If you do for a given project, it will apply for all its dependencies.
I see, thanks. And the second one is about that 1% of cases when incremental compilation works not so well. So did you encounter these cases in your... So for example, that's macro-based stuff that doesn't really sometimes work with incremental compilation. Did you have that cases, and if you had, like, how did you handle them?
Okay, so I don't have... So the question was, if you got, there was 1%, or I would say 5% places where the incremental compilation doesn't work, like macros, if I have anything special for that. So my answer is no. I mean, I roll on the incremental compiler for that, and I'm trying to also contributing to Zing, and I'm trying to fix the problem in Zing because this is the place where it should be fixed. But my general opinion, if you go to macros, and macros are never really well supported by incremental compiler because there is on macros there is only like 3 options. Either you just ignore a macros and you ask for the troubles. Or you just any changing macro gets recompiled every usage of macro, which is really, really slow, especially if you, like, for example, you want to change something in cats and or other library like that. And the third option, you have to know what you are doing and behave and try to invalidate yourself whatever needs to be changed. So in the short words, I don't have anything special for these cases.
I see, thanks.
So I have a question about, maybe I missed that part, but publishing. So if I push my code to a continuous integration server, would I be able to publish the cache with my artifacts? For example, if it releases the latest snapshot or whatever, would I be able to publish that to a Maven repository? Or because your example was S3, but have you?
Okay. The question was, if I got the CI integration and I'm doing a publishing, is my cache will be published there to, let's say, Maven, Sonatype, or whatever artifact repository that is used there, or just S3. So S3 was just an example for different workflow, and it was for pull request verifications. And if you got the CI and you want to publish your caches alongside your binaries, the cache release is for you. So it adds another artifact to what is published anywhere. And this is a normal Maven or Ivy artifact, depending on the layout of the repository, that with proper definition might be resolved. And this is what I'm doing with the cache load released option. If you want like the S3 example, maybe it wasn't that clear, was example when you want to cache the output for the, sorry guys, for the, for the PR verifications, when you produce a cache for each merges. So S3 is a good candidate because it's like accessible, it's quite cheap and quite fast. That is why I integrate with S3. So the short question is, yes, it will get published. Of course, if you configure that, and remember, this is still a beta feature.
Okay, thank you.
So I'll be happy to get any feedback from you.
Do you have any sort of like the recommendation or some sort of stats about what code size it would make sense to start adopting these type of cached build or cached strategy? Because you do have to pay some cost in downloading or in uploading, right? But after, like, do you see like after a certain code size, it will start to make sense more, or when you have X number of people, you have network effects or something like that?
I mean, the numbers like from the production I can give you, it's only for the really huge code base where the cache weighs like 2 gigabytes or more. Sorry, there is 400 megabytes for pure zips and analysis, and the rest is the jars. And in the project this size, you should definitely do that. For smaller, I mean, accessing I/O, especially on Linux machines, is quite easy, quite cheap, and even with the smallest project I got there for like there's I don't know maybe 20 Scala classes, not much bytecode generated, you are still like I don't know 2 seconds better with that. Of course, this is like if your project compiled for a minute, it probably doesn't make sense to invest any time in that because minute is nothing, more or less. If your project compiled for 10, then you should consider that because it will reduce the compilation time, in my opinion, like to at most 2 minutes. I don't have that much of data from the production. I mean, I can run some tests, but unless I got really like real use cases, like somebody will start to use that with different stuff. Like I don't know, there is a pull request, and I can test on merge pull request, but they are all green. And it should be tested also on the failed one. So you publish something to CI, and the test failed or the compilation failed, and this is also the data point I need to use, whether it was faster or not. So the short question is I don't have data. For what I can guess from my experience, if your project compiled around 5 minutes, you will see benefits. If it's more, the benefits will like grow. Because the only thing that you need to, the factor that you need to consider is like how much time is 80% of your compilation time. Because this is more likely what the speed up you will get. So if the 80% of your compilation time for the full build, it's a minute, it doesn't. If it's like 8 minutes, now it starts to matter more.
And I have another kind of question / comment is if you're using SBT on the for the CI, if you have a incremental compilation information, you can run the test quick, which only tests the stuff that was changed. So I thought that could be an interesting thing you could do when you're doing a PR. I mean, that could be a little dangerous thing to do, but you could just test only the thing that was affected if you have thousands of test cases.
So the question, maybe observation was that if you got incremental compilation, you can do test quick on the CI. This is actually a really good thing. I didn't think about that. Maybe it is a little bit scary because right now you don't only compile everything, but also you don't test everything, and you learn to like depends too much on the incremental compiler. And we all know that incremental compiler has places where it does not work at all, like for example static fields inlining in the code. But yeah, it's your choice. You can do that. I mean, if you got the incremental compilation, you will get test quick for free. So yeah, this is a really good point. Okay, so I don't see any more hands. If there is one, please wave so I can. Okay, no. So thank you a lot and for coming. I should say that you probably need to rate this talk, but you don't need to if you don't like. And thank you for coming.